how you can get data from online participants in survey format. Now, the nice thing about surveys is, they're really easy to do. They're very easy to set up, and they're really easy to send out to large groups of people. You can get tons of data really fast. On the other hand, the same way that they're easy to do, they're also really easy to do badly. The problem is that the questions you ask, they can be ambiguous, they can be double-barreled, they can be loaded, and the response scales can be confusing. So if you say, I never think this particular way, and a person puts strongly disagree, they may not know exactly what you're trying to get at. So you have to take special effort to make sure that the meaning is clear, unambiguous, and that the rating scale, the way that people respond, is very clear and they know where their answer falls. Which gets us into one of the things about people behaving badly, and that is beware the push-pull. Now, especially during election time, like we're in right now, a push-pull is something that sounds like a survey, but really what it is a very biased attempt to get data, just fodder for social media campaigns, or I'm going to make a chart that says that 98% of people agree with me. A push-pull is one that's so biased, there's really only one way to answer to the questions. This is considered extremely irresponsible and unethical from a research point of view. Just hang up on them. Now, aside from that egregious violation of research ethics, you do need to do other things like watch out for bias in the question wording, in the response options, and also in the sample selection, because any one of those can push your responses off one way or another without you really being aware that it's happening. So in sum, let's say this about surveys. You can get lots of data quickly. On the other hand, it requires familiarity with the possible answers in your audience, so you know sort of what to expect. And no matter what you do, you need to watch for bias to make sure that your answers are going to be representative of the group that you're really concerned about understanding. The very last thing I want to talk about in terms of data sourcing is to talk about the next steps. And probably the most important thing is, don't just sit there. I want you to go and see what you already have. Try to explore some open data sources. And if it helps, check with a few data vendors. And if those don't give you what you need to do your project, then consider making new data. Again, the idea here is get what you need and get going. Thanks for joining me, and good luck on your own projects. Welcome to Coding in Data Science. I'm Bart Poulson. And what we're going to do in this series of videos is we're going to take a little look at the tools of data science. So I'm inviting you to know your tools, but probably even more important than that is to know their proper place. Now, I mention that because a lot of the times when people talk about data tools, they talk about it as though that were the same thing as data science, as though they were the same set. But I think if you look at it for just a second, that's not really the case. Data tools are simply one element of data science, because data science is made up of a lot more than the tools that you use. It includes things like business knowledge. It includes the meaning making and interpretation. It includes social factors. And so there's much more than just the tools involved. That being said, you will need at least a few tools. And so we're going to talk about some of the things that you can use in data science if it works well for you. In terms of getting started, the basic things, number one is spreadsheets. It's the universal data tool, and I'll talk about how they play an important role in data science. Number two is a visualization program called Tableau. There's Tableau Public, which is free, and there's Tableau Desktop, and there's also something called Tableau Server. But Tableau is a fabulous program for data visualization, and I'm convinced for most people provides the great majority of what they need. And though, while it's not a tool, I do need to talk about the formats used in web data because you have to be able to navigate that when doing a lot of data science work. Then we can talk about some of the essential tools for data science. Those include the programming language R, which is specifically for data. There's the general purpose programming language Python, which has been well adapted to data. And there's the database language SQL, or SQL for structured query language. Then if you want to go beyond that, there are some other things that you can do. There are the general purpose programming languages C, C++, and Java, which are very frequently used to form the foundation of data science, and sort of high level production code is going to rely on those as well. There's the command line interface language, Bash, which is very common as a very quick tool for manipulating data. And then there's the sort of wildcard, supercharged regular expressions, or regex. We'll talk about all of these in separate courses. But as you consider all the tools that you can use, don't forget the 80-20 rule, also known as the Pareto principle. And the idea here is that you're going to get a lot of bang for your buck out of a small number of things. And I'm going to show you a little sample graph here. Imagine that you have 10 different tools, and we'll call them A through B. A does a lot for you, B does a little bit less, and it kind of tapers down to you've got a bunch of tools that do just a little bit of stuff that you need. Now, instead of looking at the individual effectiveness, look at the cumulative effectiveness. How much are you able to accomplish with a combination of tools? Well, the first one's right here at 60% where the tool started. Then you add on the 20% from B and it goes up, and then you add on C and D, and you add up little smaller pieces. And by the time you get to the end, you've got 100% of effectiveness from your 10 tools combined. The important thing about this is you only have to go to the second tool. That's 2 out of 10. So that's B. That's 20% of your tools. And in this made up example, you've got 80% of your output. So 80% of the output from 20% of the tools. That's a fictional example of the Pareto principle, but I find in real life it tends to work something approximately like that. And so you don't necessarily have to learn everything, and you don't have to learn how to do everything in everything. Instead, you want to focus on the tools that will be most productive, and specifically most productive for you. So in sum, let's say these 3 things. Number 1, coding, or simply the ability to manipulate data with programs and computers. Coding is important, but data science is much greater than the collection of tools that's used in it. And then finally, as you're trying to decide what tools to use and what you need to learn and how to work, remember the 80-20 rule. You're going to get a lot of bang from a small set of tools. So focus on the things that are going to be most useful for you in conducting your own data science projects. As we begin our discussion of coding and data science, I actually want to begin with something that's not coding. I want to talk about applications, or programs that are already created that allow you to manipulate data. And we're going to begin with the most basic of these, spreadsheets. We're going to do the rows and columns and cells of Excel. And the reason for this is you need spreadsheets. Now, you may be saying to yourself, no, not me. Because you know what? I'm fancy. I'm working in my big set of servers. I got fancy things going on. But you know what? You too, fancy people, you need spreadsheets as well. And there's a few reasons for this. Most importantly, spreadsheets can be the right tool for data science in a lot of circumstances. There are a few reasons for that. Number 1, spreadsheets, they're everywhere. They're ubiquitous. They're installed on 1 billion machines around the world. And everybody uses them. They probably have more data sets in spreadsheets than anything else. And so it's a very common format. Importantly, it's probably your client's format. A lot of your clients are going to be using spreadsheets for their own data. I've worked with billion-dollar companies that keep all of their data in spreadsheets. And so when you're working with them, you need to know how to manipulate that and how to work with it. Also, regardless of what you're doing, spreadsheets, or specifically CSV, comma-separated value files, are sort of the lingua franca, or the universal interchange format for data transfer to allow you to take it from one program to another. And then, truthfully, in a lot of situations, they're really easy to use. And if you want a second opinion on this, let's take a look at this ranking. That is a survey of data mining experts. It's the KD Nuggets data mining poll. And these are the tools they most use in their own work. And look at this. Lowly Excel is 5th on the list. And in fact, what's interesting about it, it's above Hadoop and Spark, 2 of the major big data fancy tools. And so Excel really does have a place of pride in a toolkit for a data analyst. Now, since we're going to sort of the low-tech end of things, let's talk about some of the things that you can do with a spreadsheet. Number 1, they're really good for data browsing. You actually get to see all of the data in front of you, which isn't true if you're doing something like R or Python. They're really good for sorting data. sort by this column, then this column, then this column. They're really good for rearranging columns and cells and moving things around. They're good for finding and replacing and seeing what happened so you know that it worked right. Some more uses. They're really good for formatting, especially conditional formatting. They're good for transposing data, switching the rows and the columns. They make that really easy. They're good for tracking changes. Now, it's true if you're a big fancy data scientist, you're probably using GitHub, but for everybody else in the world, spreadsheets and the tracking changes is a wonderful way to do it. You can make pivot tables. That allows you to explore the data in a very hands-on way, in a very intuitive way. And they're also really good for arranging the output for consumption. Now, when you're working with spreadsheets, however, there's one thing you need to be aware of. They're really flexible, but that flexibility can be a problem. And that when you're working in data science, you specifically want to be concerned about something called tidy data. That's a term I borrowed from Hadley Wickham, very well-known developer in the R world. Tidy data is for transferring data and making it work well. There's a few rules here that undo some of the flexibility inherent in spreadsheets. Number one, what you want to do is have a column be equivalent to the same thing as a variable. Columns, variables, they are the same thing. And then rows are exactly the same thing as cases. And then you have one sheet per file, and that you have one level of measurement, say individual, then organization, then state per file. Again, this is undoing some of the flexibility that's inherent in spreadsheets, but it makes it really easy to move the data from one program to another. Let me show you how all this works. You can try this in Excel. If you've downloaded the files for this course, we simply want to open up this spreadsheet. Let me go to Excel and show you how it works. So when you open up the spreadsheet, what you get is totally fictional data here that I made up, but it's showing sales over time of several products at two locations, like if you're selling stuff at a baseball field. And this is the way spreadsheets often appear. We got blank rows and columns. We got stuff arranged in a way that makes it easy for the person to process it. And we got totals here and with formulas, putting them all together. And that's fine. That works well for the person who made it. And then that's for 1 month. And then we have another month right here. And then we have another month right here. And then we combine them all for the first quarter of 2014. We've got some headers here, and we've got some conditional formatting and changes. And if we come to the bottom, we've got a very busy line graphic that eventually loads. It's not a good graphic, by the way, but similar to what you will often find. So this is the stuff that, while it may be useful for the client's own personal use, you can't feed this into R or Python. It'll just choke and it won't know what to do with it. And so you need to go through a process of tidying up the data. And what this involves is undoing some of this stuff. So for instance, here's data that is almost tidy. Here we have a single column for the date, a single column for the day, a column for the site. So we have two locations, A and B. And then we have 6 columns for the 6 different things that are sold and how many were sold on each day. Now, in certain situations, you would want the data laid out exactly like this. If you're doing, for instance, a time series, you'll do something vaguely similar to this. But for true tidy stuff, we're going to collapse it even further. Let me come here to the tidy data. And now what I've done is I've created a new column that says, what is the item being sold? And so, by the way, what this means is that we've got a really long data set now. It's got over 1,000 rows. Come back up to the top here. But what that shows you is that now it's in a format that's really easy to import from one program to another. That makes it tidy, and you can remanipulate it however you want once you get to each of those. So let's sum up our little presentation here in a few lines. Number one, no matter who you are, no matter what you're doing in data science, you need spreadsheets. And the reason for that is that spreadsheets are often the right tool for data science. Keep one thing in mind though, and that is as you're moving back and forth from one language to another, tidy data or well-formatted data is going to be important for exporting data into your analytical programmer language of choice. As we move through coding and data science, and specifically the applications that can be used, there's one that stands out for me more than almost anything else, and that's Tableau and Tableau Public. Now, if you're not familiar with these are visualization programs. The idea here is that when you have data, the most important thing you can do is to first look and see what you have and work with it from there. And in fact, I'm convinced that for many organizations, Tableau might be all that they really need. It will give them the level of insight that they need to work constructively with data. So let's take a quick look by going to tableau.com. Now, there are a few different versions of Tableau. Right here, we have Tableau Desktop and Tableau Server, and these are the paid versions of Tableau. They actually cost a lot of money unless you work for a nonprofit organization, in which case you can get them for free, which is a beautiful thing. What we're usually looking for, however, is not this paid version, but we're looking for something called Tableau Public. And if you come in here and go to products, and we've got these 3 paid ones, come over here to Tableau Public. And we click on that, it brings us to this page. It's public.tableau.com. And this is the one that has what we want. It's a free version of Tableau with one major caveat. You don't save files locally to your computer, which is why I didn't give you a file to open. Instead, it saves them to the web in a public form. So if you're willing to trade privacy, you can get an immensely powerful application for data visualization. That's a catch for a lot of people, which is why people are willing to pay a lot of money for the desktop version. And again, if you work for a nonprofit, you can get the desktop version for free. But I'm going to show you how things work in Tableau Public. So that's something that you can work with personally. The first thing you want to do is you want to download it. And so you put in your email address, you download, it's going to know what you're on. It's a pretty big download. And once it's downloaded, you can install it and open up the application. And here I am in Tableau Public right here. This is the blank version. By the way, you also need to create an account with Tableau in order to save your stuff online and to see it. We'll show you what that looks like. But you're presented with a blank thing right here. And the first thing you need to do is you need to bring in some data. I'm going to bring in an Excel file. Now, if you've downloaded the files for the course, you'll see that there's this one right here, DSO322 Tableau Public .xlsx. It's a Excel file. And in fact, it's the one that I used in talking about spreadsheets in the first video in this course. I'm going to select that one and I'm going to open it. And a lot of programs don't like bringing in Excel because it's got all the worksheets and all the weirdness in it. This one works better with it. But what I'm going to do is I'm going to take the tidy data. By the way, you see that it put them in alphabetical order here. And I'm going to take tiny data. I'm just going to drag it over to let it know that it's the one that I want. And now what it does is it shows me a version of the data set along with things that you can do here. You can rename it. You can create bin groups. There's a lot of things that you can do here. I'm going to do something very, very quick with this particular one. Now I've got the data set right here. What I'm going to do now is I'm going to go to a worksheet. That's where you actually create stuff. Cancel that and go to worksheet 1. Okay, this is a drag and drop interface. And so what we're going to do is we're going to pull the bits and pieces of information we want to make graphics. There's immense flexibility here. I'm going to show you 2 very basic ones. I'm going to look at the sales of my fictional ballpark items. So I'm going to grab sales right here. And I'm going to put that as the field that we're going to measure. Okay, and you see it put it down right here. And this is our total sales. We're going to break it down by item and by time. So let me take item right here. And you can drag it over here, or I can put it right up here into rows. Those will be my rows, and that's how many we've sold total of each of the items. Fine, that's really easy. And then let's take date, and we'll put that here in columns to spread it across. Now, by default, it's doing it by year. I don't want to do that. I only have 3 months of data. And so what I can do is I can click right here and I can choose a different time frame. I can go to quarter, but that's not going to help because I only have 1 quarter's worth of data. That's 3 months. I'm going to come down to week. Actually, let me go to day. If I do day, you see it gets enormously complicated. So that's no good. So I'm going to back up to week. And I've got a lot of numbers there, but what I want is a graph. And so to get that, I'm going to come over here and click on this and tell it that I want a graph. And so we're seeing the information, except it lost item. So I'm going to bring item and I'm going to put it back up into this graph to say this is a row for the data. And now I've got rows for sales by week for each of my items. That's great. I want to break it down one more by putting in the site, the place that it's sold. And so I'm going to grab that and I'm going to put it right over here. And now you see I've got it broken down by the item that is sold and the different sites. And I'm going to color the sites. And all I got to do to that is I'm going to grab site and drag it onto color. Now I've got two different colors for my sites. And this makes it a lot easier to tell what's going on. And in fact, there's some other cool stuff you can do. One of the things I'm going to do is I can come over here to analytics and I can tell it, for instance, to put an average line through everything. So I'll just drag this over here and say, now we have the average for each line. That's good. And I can even do forecasting. Let me get a little bit of a forecast right here. I'll drag this on. And if you go over here, I can get this out of the way for a second. Now I have a forecast for the next few weeks. And that's a really convenient, quick and easy thing. And again, for some organizations, that might be all that they really need. And so what I'm showing you here is the absolute basic operation of Tableau, which allows you to do an incredible range of visualizations and manipulate the data and create interactive dashboards. There's so much to it, and we'll show that in another course. But for right now, I want to show you one last thing about Tableau Public, and that is saving the files. So now when I come here and save it, it's going to ask me to sign into Tableau Public. Now I sign in, and it asks me how I want to save this. Same name as the video. There we go, and I'm going to hit save. And then that opens up a web browser. And since I'm already logged into my account, see, here's my account, my profile. Here's the page that I created. And it's got everything I need there. I'm going to edit just a few details. I'm going to say, for instance, I'm going to leave its name like that. I could put more of a description in there if I wanted. I can allow people to download the workbook and its data. I'm going to leave that there so you can download it if you need to. If I had more than one tab, I would do this thing that says show the different sheets as tabs. Hit save. And there's my data set. And also, it's published online and people can now find it. And so what you have here is an incredible tool for creating interactive visualizations. You can create them with drop-down menus and you can rearrange things and you can make an entire dashboard. It's a fabulous way of presenting information. And as I said before, I think that for some organizations, this may be as much as they need to get really good, useful information out of their data. And so I strongly recommend that you take some time to explore with Tableau, either the paid desktop version or the public version, and see what you can do to get some really compelling and insightful visualizations out of your work in data science. For many people, their first experience of coding in data science is with the application SPSS. Now, I think of SPSS, and the first thing that comes to my mind is sort of life in the ivory tower, though this looks more like, Harry Potter. But if you think about it, the package name SPSS comes from Statistical Package for the Social Sciences, although if you ask IBM about it now, they'll act like it doesn't stand for anything. But it has its background in social science research, which is generally academic. And truthfully, I'm a social psychologist, and that's where I first learned how to use SPSS. But let's take a quick look at their webpage, ibm.com/SPSS. If you type that in, that'll just be an alias. It'll take you to IBM's main webpage. Now, IBM didn't create SPSS, but they bought it around version 16, and it was very briefly known as PASW, Predictive Analytics Software. That only lasted briefly, and now it's back to SPSS, which is where it's been for a long time. SPSS is a desktop program. It's pretty big. It does a lot of things. It's very powerful. It's used in a lot of academic research. It's also used in a lot of business consulting, management, and even some medical research. And the thing about SPSS is it looks like a spreadsheet, but it has drop-down menus to make your life a little bit easier compared to some of the programming languages that you can use. Now, you can get a free temporary version. If you're a student, you can get a cheap version. Otherwise, SPSS costs a lot of money. But if you have it one way or the other, when you open it up, this is what it's going to look like. I'm showing SPSS version 22. Now, it's currently on 24. And the thing about SPSS versioning is in any other software package, these would be point updates. So I sort of feel like we should be on 17.3 as opposed to 22 or 24, because the variations are so small that anything you learn from the earlier ones is going to work in the later ones. And there's a lot of backwards and forwards compatibility. So I'd almost say that this one, the version you have, practically doesn't matter. You get this little welcome splash screen, and if you don't want to see it anymore, you can get rid of it. I'm just going to hit cancel here. And this is our main interface. Looks a lot like a spreadsheet. The difference is you have a separate pane for looking at variable information, and then you have separate windows for output, and then an optional one for something called syntax. But let me show you how this works by first opening up a data set. SPSS has a lot of sample data sets in them, but they're not easy to get to, and they're really well hidden. On my Mac, for instance, let me go to where they are. In my Mac, I go to the Finder. I have to go Mac to Applications, to the folder IBM, to SPSS, to Statistics, to 22, the version number, to Samples. Then I have to say I want the ones that are in English. And then it brings them up. The .sav files are the actual data files. There are different kinds in here. So .sps is a different kind of file. And then we have a different one about planning analyses. So there are versions of it. I'm going to open up a file here called marketvalues.sav. It's a small data set in SPSS format. And if you don't have that, you can open up something else. It really doesn't matter for now. By the way, in case you haven't noticed, SPSS tends to be really, really slow when it opens. It also, despite being a version 24, tends to be kind of buggy and crashes. And so when you work with SPSS, you want to get in the habit of saving your work constantly and also being patient when it's time to open the program. So here's a data set that just shows addresses and house values and square feet for some information. This, I don't even know if this is real information. It looks artificial to me. But SPSS lets you do point and click analyses, which is unusual for a lot of things. So I'm going to come up here and I'm going to say, for instance, make a graph. I'm actually going to use what's called a legacy dialog to get a histogram of house prices. So I simply click values, put that right there, and I'll put a normal curve on top of it and hit OK. And then it's going to open up a new window, and it opened up a microscopic version of it here. So I'm going to make that bigger. This is the output window. And so this is a separate window, and it has a navigation pane here on the side. It tells me where the data came from, and it saves the command here. And then, there's my default histogram. And so we see most of the houses were right around $125,000, and then they went up to at least 400,000. I have a mean of 256,000, a standard deviation of about 80,000, and there's 94 houses in the data set. Fine, that's great. The other thing I can do is if I want to do some analyses, let me go back to the data just for a moment. For instance, I can come here to analyze and I can do descriptives. I'm actually going to do one here called explore. And I'll take the purchase price and I'll put it right here. And I'm going to get a whole bunch of stuff just by default. I'm going to hit OK. And it goes back to the output window. Once again, made it tiny. And so now you see beneath my chart, I now have a table and I've got a bunch of information, a stem and leaf plot, and I've got a box plot too. A great way of checking for outliers. And so this is a really convenient way to save things. You can export this information as images. You can export the entire file as an HTML. You can do it as a PDF or a PowerPoint. There's a lot of options here, and you can customize everything that's on here. Now, I